So hi, my name is Ruth Dewar, and I'm here kind of as the main organizer of this session. We have many of my co-organizers here as well. Um, we have Nancy Ritchie, we have Kate, um, and man, I can't see everybody's name. I don't know if Gary's here. Yep, he is. Now I can see him. And Pierre, of course, is another major member of our group. But in any case, this is a session sponsored by the Semantic Harmonization Cluster of ESIP, which is one of the clusters under the Semantic Technologies Committee. And so today's topic is semantics adoption in the earth and environmental sciences, successes and roadblocks. And apparently I can't change my screen. So if you haven't checked in yet, which it looks like everybody's doing, please do so now. I have bit.lys and things like that for all of the various links that we have here. So feel free. And I believe Allison, etc., will be posting those in the chat as we go along. And I'd like to start off with a land acknowledgement where I'm acknowledging that I'm participating from the traditional territories of the Ute, Cheyenne, Arapaho, and Oceti-Sakowin peoples. I acknowledge its legacy and find inspiration from this land. The Oceti-Sakowin peoples are sometimes called Sioux, though my understanding is that that's not a term they like. We each have a responsibility to consider what it means to acknowledge the history and legacy of colonialism in our history as a nation and as a community. Throughout the discussion during this session and throughout the ESIP winter meeting, we note the privileges we enjoy today because of colonialism, and we strive not to perpetuate a colonial future. I just wanted to give you a little bit of a status as to what's going on in the harmonization cluster. For the last couple of years, we've been working on harmonizing several semantic resources related to the cryosphere. And we've gotten a paper that actually is going to kind of talk about what we learned during that process. And that paper is in finalization. I had hoped to actually have a complete good draft to share, but I didn't quite get there. I'm in the process of weeding something like 37 to 40 pages worth of text down into something like manageable. But in any case, the group is ready to start thinking about what our next steps are. And so that's partly the reason for this talk. One of the things I should note is when we talk about semantic resources, we're talking about a whole host of things, everything from controlled vocabularies all the way up to formal ontologies. And this is what is often called a semantic ladder, which is showing where things, basically showing how things become increasingly machine readable or machine understandable as you go up to the right here. So down at the lower left-hand corner, basically pretty much what you have is strings. Computers can certainly use strings, but that doesn't mean they're going to be able to reason about them. In the upper right-hand corner, which is where you have much stronger semantics, there you have rules and axioms where a machine can actually do reasoning. I should note that in order to be truly fair, if you read the details of the FAIR principles, you cannot really be fair, interoperable, unless you've kind of moved up to that upper right-hand corner. In the semantic harmonization cluster, we have worked with 3 primary resources. One, the GCW glossaries compiled by the Global Cryosphere Watch. Basically, they took all of the cryosphere glossaries worldwide that they could find. There's some 27 of them, I think. and brought them all together and actually asked me to look at them and figure out where there were issues, where definitions could be combined, where they needed to be split, where the community needs to actually think about what they really mean, and things like that. The other two resources that we've been working with are the suite set of ontologies, which was originally developed about 20 years ago by Rob Raskin and was originally based off the GCMD keywords, but hasn't really kept pace with the GCMD keywords after Rob died, and it took JPL a good long time to open source that, and it's now under ESIP's technology committee, Semantic Technologies Committee, auspices to bring it forward. And last, and certainly not least, is the ENVO ontology from the OBO Foundry, which is the environment ontology, which is a full-fledged domain kind of ontology for everything to do about the environment. So these are the three things that we've been putting together, harmonizing. And I will note that as a result of that work, we've kind of come up with sort of, this is what a standard process for doing that kind of work would look like. I'm not going to talk through this. I'm kind of using this as an ad for someday when this paper comes out. Please read it and comment. I will note, if you're interested in reading a draft and even participating, please just let us know. Okay, turning our attention to the session, there's really two goals here. One is to acquaint this community with some of the existing and budding semantic success stories in the earth and environmental sciences. One of the things I keep hearing is, oh, nobody's ever done semantics successfully in the earth sciences. And I'm not convinced that I believe that that's true, and I guess we're about to find out. And then secondly, to learn from the ESIP community about any roadblocks that are holding up semantics adoption. I think we started that process yesterday in Ryan McGranahan's session, but we'll do a little bit deeper dive into that topic. For one thing, that may well inform the several ESIP clusters and the Semantic Technologies Committee of things they should do to move the whole field forward. So with that, I would like you all to go to this Slido poll. Somebody please drop that link. Or you can just go to slido.com and enter semantics adoption and answer these questions. This is the first question. And let's see, there's some 56 people here. So we're just trying to get an overview of who's using what. In their work. And the numbers are still going up. Okay, 20 people left.
Well, everybody can answer because there's none of the above. I did answer.
Okay. Well, the number's still increasing, so I'll just wait another minute. And this just shows how you shouldn't allow people like me who don't know what they're doing in this regard to create these polls. Seriously.
No, but this is fun.
Okay, well, it just went up again. Okay, we still have people participating. But I think the results have been looking pretty stable, which is everybody and his brother practically uses controlled vocabularies. Many people have data schemas that they use. About half the people, a little more, are actually using schema.org. That's good news for the schema.org cluster. And a goodly chunk of people are using glossaries and taxonomies of some sort. And with that, I think we'll move to the next question. Hold on. I have to make sure I know how to do that. There we go. And so then the question is, how important is data interoperability to your work? All right, starting off good at 100%, extremely. Up to 30 already. That's pretty good. Okay, that looks like it's getting, well, okay. A few more maybe coming in, maybe. Well, I actually am surprised at the bottom two answers. Nobody's clicking on not at all, or I don't know. So that's kind of cool. And the vast majority thinks data interoperability is extremely important. Though it's not clear to me, and I didn't ask this question, how many people truly realize that you can't have fair data without incorporating semantics into your work at a pretty high level. But in any case, thank you very much for participating there. We'll keep that around. We now we now have about 40 minutes for presentations from speakers. I will be switching over to doing the audience Q&A version of Slido so that you can actually enter your questions as the speakers present. We're not going to give them time to answer questions at the end of their talk, but after all four talks, we will spend about 10 minutes answering any of the top voted questions. And then also, we would like to capture any questions that didn't get answered in real time in the notes document and have the speakers deal with that there. So with that, our first speaker is, wow, I can't find my notes, is Chantel Verhey, who is talking about the Polder project. So I will stop sharing, and Chantel, take it away.
Thank you, Ruth. Let me pull up my slides real quick. Let's see. Awesome. Okay. Everybody sees the presentation view just fine and everything? I don't hear any complaints. Okay, perfect. So hi, everybody. My name is Chantel. I'm a research associate with the International Technology Office and World Data Systems, and I'm here to help share our successes and specifically as my position as the co-chair of the Polder Working Group. So first, the research data management community in general, and I'm sure a lot of you can identify with these, have some overarching challenges that are presented throughout. So capacity issues such as funding, making sure you have consistent funding, trained personnel to do touch on subjects such as semantic technologies, and maintenance uncertainty for any technologies that are used or built, and lack of standardization between vocabularies, best practices within the community, metadata schemas depending on your domain expertise and everything. And then specifically, we noticed that there was a big problem with locating domain-specific repositories. So example, general domains versus, say, polar specific, and not necessarily polar data, finding it in a general repository and whatnot. So your another example would be like your library or institutional repository versus your polar data catalogs out there. So in order to set the stage in one approach that it seems like this community, at least 50% of us are very familiar with, is schema.org. And the light use implementation that has been gaining traction within the research data management community. Although I know the other 50% of us here might not have a clue what schema.org is or anything like that. So it was initially built by the 5 main search engines. So your Googles, your Yahoos, and I'm blanking on the other ones. I know you guys can fill in the blanks. But how do we use it specifically to research data management and data interoperability? And I will elaborate that on a little bit. But one of the main attractions to schema.org use is that if a repository implements any schema.org markup, that they are according to 2 requirements. Like as long as you have your title and your description, you can actually become discoverable in Google Dataset Search. Google Dataset Search is supposed to be the Google Scholar for the data world. I'm sure it's gaining traction and everything, but we've been able to adapt schema.org for our own purposes and use it in different ways. So for those of us who may not be super abreast with the schema.org world, which I wasn't when I first stepped onto the scene, I've created a schema.org for research data managers, a primer, and it kind of comes down to the basic overarching level of what schema.org is, why research data managers should be, or kind of explaining why people are paying attention to it. And it is officially published at the International Journal of Big Data Management. So if anybody wants a link, it is open access and ready for anybody who's interested in that too. And I'm happy to send that over to anybody who's interested. So specifically, schema.org is embedded within your landing pages. So it's JSON LD based, and it's an extension of JSON. The standard way of avoiding ambiguity when expressing linked data in JSON, so that the data is structured in a format which is parsable by machines. So in context, JSON LD allows 2 applications to map terms to IRIs. And in practice, this type of page markup tells an application the origin or vocabulary that contains the terms like type and name, etc. So, I mean, that is a little bit more on the technical side of things, where a lot of the work that was done with schema.org first began in our world was with the Research Data Alliance Research Metadata Schemas Working Group. So schema.org can be a lightweight, but also can be very subjective when you implement it. We're starting at the metadata level. So the RDA Research Metadata Schemas Working Group first completed a list of 15 crosswalks, and these crosswalks included a list of your schema.org terms and mapped them specifically to 15 different metadata schemas. And they published guidelines for how to actually implement the schema.org markup into your metadata standards, alongside the actual crosswalk mappings. So I know this is a lot of information all at once on the screen in an Excel, everybody's favorite. But this is kind of example of I think there's 5 or 6 of the metadata schemas that are up, and examples of how it was actually mapped one-to-one, so it can be interoperable and machine readable across the board. For, again, those of us that may not be super technical, the WDS-ITO has created a set of schema.org crosswalk visualizations. So this includes anybody to kind of go and just get more of a visual one-to-one mapping to see the different relationships across the board between schema.org and the different metadata schemas. So this includes like a filter table where you can actually look at each specific metadata schema and see the mappings to schema.org terms. You can search for specific terms one-on-one, Sankey diagrams to see which term actually has the best mapping across the board of metadata schemas and whatnot. So it's very interesting to play around on, and I'm happy to drop the link to that as well in the chat later on. So building off of the RDA research metadata schemas work, so that was more kind of multidisciplinary across the board. We stumbled upon Science on Schema. So I know that they have a presentation session tomorrow that everybody should attend. And they just released the 1.3 release of the new guidelines and documentation, which has included new terms and guidance. So that would be a good one. Just to help promote them even more is that they do have a cluster meeting on the fourth Thursday of every month. So we definitely highly recommend anybody joining that. So schema.org is the Science on Schema, also known as SOSO. I'll try not to acronym out too much. SOSO is the earth science application of schema.org into earth science repositories. And from there, we stumble upon Polder. So Polder is the Polar Data Discovery Enhancement Research. This is the community in the polar RDM world that the community came together and said, you know, this is a problem. This is what's happening with how do we enhance our interoperability and data discovery using schema.org. So they have been having discussions for, I think we're up to 6 or 7 years now. It's hard to keep track. But the community came together and said that we want to actually adapt schema.org and the SOSO guidelines for polar specific repositories and to help promote data discovery as best as possible. So this first stemmed from utilizing a best practices document, which we have now officially had our first version completed, which is great. Which I also, again, drop the link. We'll have lots of different resources dropped in the chat after my presentation. But the best practices outlines the actual terms mapped from schema.org and what are most important to the polar community in order to have our enhanced data discovery. And then through there, it's not one thing just to mark up your metadata with the best practices recommendations, but it's actually to have a search, federated search created. So you can actually go to one single user interface and search across all of the polar data repositories globally.
Two minute warning. Sorry, 2 minute warning.
Thank you. No worries. I will try to keep going. So how I like to describe it is you have a schema.org as your top general lightweight layer, and then you have your SOSO kind of picking and choosing the terms that they want for the earth science community, and then you have Polder, again, picking and choosing our apples, what is most applicable to our community. So there's differences between the Polder implementation and SOSO, which is Polder includes mandatory and recommended terms, where SOSO is more of guidance on how you would implement the markup generally. And I'm just going to try to keep rolling to keep on time. So Polder best practices, I think we're up to 10 terms that is either mandatory or recommended in order to be included in the Polar Federated Search. The benefits of a Polar Federated Search, you can access data all in one spot. So we've been a year into production, which is great. This is kind of the user interface that you can actually, we have temporal searches, spatial search, keyword search. I'll do a spatial search, just a quick snippet. And we are up to 14 different repositories, 14 plus. So there's 3 different ways that you can be integrated into the Polar Federated Search. It's through Data One. CCADI also has been included, which has, I believe there are 10 different repositories. And then we can be harvested specifically through the schema.org implementation. I'll try to skip through it real quick. So you can kind of see here that you have the general layer, you do the schema.org markup in your repository, you go into the federated search, harvested and pushed out into the one single user interface. So I know I'm getting close to time and we'll just try to.
Yeah, it's time. Yeah.
Okay. Well, my closing sentiment are the challenges that we're facing is sustainability. So we wanted to make sure it was open source and portable, clearly laid out documentation, cost effective, but of course that presents its own challenges in the end as a result. So sorry that I had to rush through that. But happy to answer any questions at the end, and I'll keep look at it in Slido for anything that might be in there. But thank you so much for having me.
Thanks a bunch, Chantel. That was great. And I'm sorry we were rushing you a little bit. Next up, next up is Dan Berrios on adoption of ontological data models by NASA Life Science Systems. Dan, take it away.
Okay, I should be sharing my screen. Do you see my slides?
You see your Zoom window.
Oh gosh, all right. It's changed. Give me 1 second here. Screen one, let's try that. How about now?
Yeah.
Okay, good. Hello, I'm Dan Berrios. I'm at NASA Ames Research Center. Fascinating listening to the previous talk, lots of overlap with what I'm going to talk about and what I'm working on currently. But I'm going to point out how we've adopted ontological data models and specifically ontologies in our NASA life science systems. Okay, so briefly I'll talk about FAIR, talk a little bit about ontologies. I'm going to kind of whip through these slides so I can give a little demo before the end of my time. Implementing these ontologies to increase our FAIR compliance, how we've approached that and prioritized that and summarize. Okay, so it's probably pretty obvious to everybody, especially after the previous talk and maybe previous talks previous to that in the meeting, that it's key to have metadata harmonization and linked data for scientific research data across domains and disciplines. And these are foundations for open science. They promote transparency and scientific reproducibility. I have a little bit more on that coming up. So we have a problem with currently with our NASA life science data systems in that we don't have a lot of uniformity of metadata values, meaning we lack metadata harmonization, and we don't offer a lot of metadata in linked data format like the JSON-LD format that was shown in the previous speaker's talk. So our plan, in red here you see the problems, and in green you see our plan to address those problems. We have been doing this for our life sciences data repositories over the last few years, and we continue doing this into the future. We're implementing the ISA standard. I mentioned a little bit about that in the chat, the investigation study assay standard, which was developed initially for life sciences specific data, but has been broadened to include many types of other discipline data. We're developing ontologies that can form the basis for our data models for our repositories. We're doing things like DOIs and licensing and things like that to increase our FAIR compliance. Ontologies, as was shown on the semantic ladder by Ruth in the beginning, they're kind of like souped up taxonomies. They're much more stronger in their logical descriptions of objects and properties. And for example, we are developing an ontology that has such a thing as a hardware class or a payload class or a mission class, and defining those with annotations and properties and links to and relationships to other concepts to form the foundations for our data models and our data systems. So, through that we can do automated reasoning. You could do meta-analysis much more easily with harmonized metadata and able to pull in larger sets of data for broader applications. So in the life sciences world, there's quite a bit of ontological resources already out there. OpenFoundry has been mentioned. They support the ENVO. We've developed this radiation biology ontology in the last few years specifically for areas which NASA is interested in radiation biology. There's the W3C, which has broad areas of ontological modeling available to people. And the NIH in particular for life sciences has developed a lot of ontologies, including the very massive taxonomy of of organisms called the NCBio taxon. So using those resources, Ruth and I last year and the year before engaged in trying to develop a science data discovery ontology. This was initially done using concept maps, and then we wrote code to transform these into ontologies in OWL. This has now formed the basis for other for life sciences data models for NASA life sciences data systems. And we've been using this this broad area modeling as the basis for those models. So I mentioned the radiation biology. We developed these methods sort of outlined on this slide to build these ontologies with community input and use cases, and iteratively publishing versions of them into GitHub, all in an open source framework for development, and then we publish them out to BioPortal and to OboFoundry. And then our data systems and other data systems, actually StoreDB is a European radiation biology data system, can access these ontologies and the knowledge in them and design their data models around them. So the RBO is an OboFoundry domain ontology. We are also now building an application ontology to underlie one of our systems, the Life Sciences Data Archive. We have two main life sciences repositories at NASA. What was formerly known as GeneLab is now known as the Open Science Data Repository, and I'm going to show you that in a demo in a second. And then the Life Sciences Data Archive system, which is not really all open, as a lot of it has a lot of restrictions. So there's some data kept separately in this. But as this slide outlines, we use the SDO and a lot of discussion, and we haven't even had release one of the LSDAO yet, but we anticipate we will in the near future, and we're doing it all on GitHub with community feedback and input. So this is, the technical framework. We use the ODK, the Ontology Development Kit, which is maintained by people affiliated with the OboFoundry, to have a lot of formalized methods when we develop these ontologies. And of course, eventually, as I mentioned, the archives will be using them for things like data submission, data curation, data discovery functions in these systems. So in summary, we're working a lot on frameworks to support semantic harmonization in our metadata in these systems, and trying to move towards a JSON-LD-based framework for these metadata, which traditionally have not used such advanced models to represent their metadata. We're working with the communities closely, and we're interacting with the ISA standard folks as well in our development, and feeding back to them what our thoughts are on that standard. And we're trying to move down the semantic ladder to reach down to the controlled vocabularies and pull things up higher into ontological representations whenever we can. It's a huge effort, and it's going to take quite a bit of time to do that. We are also doing some FAIR workbench and dashboard development. We're having some discussions with folks on how to do that best, and we've gotten a lot of insight actually from like the Arctic DataOne's Arctic Data Center on how to show FAIR compliance well in an interface. Okay.
2 minutes
Yep.
left. Sorry.
So I'm going to stop sharing that and try and share the other screen, which I think is screen 2. Do you see my browser here?
Yes, we do.
Okay, great. So this is the Open Science Data Repository at NASA at osdr.nasa.gov, which shows a lot of data sets listed here. If you click on one of these, and I pre-clicked on one of them to bring up the specific record for a particular data set, and your browser works. And give me a second to reload it here. I wanted to show that there are details in the metadata on this record, which are links to ontological entities. So whereas before we had been using like lower semantic ladder control vocabulary terms for things like study factors, they now link, if you click on this, to, in this particular case, an oboe foundry ontology and the NCI thesaurus representation for this concept, and puts it in a hierarchy. Now, I'm not in love with the NCIT's oboe edition, but from an ontological perspective, but I do think it's better to have that kind of a representation than to have just the controlled vocabulary kind of representation. And as I scroll down here, you'll see, you know, for things like the assay technology definition, for a growth protocol used by the study, anything that's in the highlighted blue hyperlinked style is a link out to an ontological representation. So there's just a lot of exposed metadata here for this particular experiment that does have links to things like units and things like protocols and equipment and assays entities with either within oboe foundry or other ontology servers like the OLS.
It's time. Thank you.
Okay, that's it. I'm done.
Dan, that was great.
Okay, thanks.
So Peter Pulsifer is up next with CCATI and related projects. I noticed people are putting questions for Dan, etc., in the chat. Can you please copy those over into the notes document? Because I want to preserve the questions and answers over there. I do note that very few people, like only one, has actually put a question into the Slido. But it's okay either way. In any case, Peter, take it away.
Great. Thanks very much, Ruth. And I will say I'm presenting on behalf of some colleagues, Rebecca Ingram and Alex Gow, and actually Brendan Billingsley also has been involved in this, and a whole bunch of other folks. Sorry, just trying to get, there we go. And there's a delay. So CCATI, I won't say much about given the limited time, but we're basically a consortium based in Canada, and we're trying to improve interoperability among particularly the universities and what I'll call the long tail folks in Canada. So not so much the federal agencies, although we do have partnerships with them, but trying to get all of those other data sets interoperating. And so the problem in particular that we have is that the Arctic is not defined by a particular discipline. It has many, it's a geographic domain. And so there are many different research and community-based domains that all have their own semantics and so on. And so we're trying to work across those as much as possible. And sorry, we just have some animation here. We have a number of partners in CCATI, many of whom are data centers, and some of them are very mature data centers, been around maybe a couple of decades. So they already have metadata standards and implementations of various types of standards, or not necessarily standardized for legacy stuff. So we're trying to initially, our work was on looking at metadata interoperability. So we've already seen Chantal's presentation, so there's a lot of background there, and I won't go into that. But in terms of our methodology, we started as a very simple process, looking at all our different partners that we have in CCATI, and then comparing that with the standards they're using, the different terms, and so on. That was then formalized in a tool called Protégé, which many of you will be familiar with if you're working in this space. And we created this crosswalk ontology. So how do we cross from the specific implementations in the consortium into something that's standard, whether it be schema.org or ISO 19115. And we mapped out a number of different languages, but we focused on schema.org and ISO 19115. Wherever possible, there should have been a little note there that said we did use the RDA resources that Chantal referred to. So that was the base, but it's great to have those things. But as soon as you get into implementation, some of them that, again, are 2 decades old, there can be some things that you have to do to adapt those sort of community resources. So, but they were great in terms of a foundation. So our technical approaches, what we've tried to do as much as possible is always use existing software, existing vocabularies, existing tools, et cetera, as much as possible, at least. So we became aware of the Gleaner tool, and I think Doug is on here, and Pierluigi and others who are using that as well. And so we adopted that tool, and what that does is essentially lets us go out to our partners, those data centers who are now publishing schema.org in JSON LD on their landing pages or as a full item list or graph. And we're harvesting those using JSON LD. Or in some cases, we have things like OGC's catalog services for web. So that's a more mature standard, and it's using ISO 19115. So in that case, we're harvesting from that endpoint and bringing that into our consortium-wide database or metadatabase. So just, a bit technical for some maybe, but we've taken, in this case, the JSON LD, and we do convert it to a format called Turtle, or serialization called Turtle, which is just a different way to represent the RDF model, or resource description framework model. And that's just many of the tools we're using can use that, and it's a little easier for some to understand who are just coming into this space. Some of our technical people. But we also use the JSON LD, and that's definitely when we're facing our end users or our harvesters, and that JSON LD tends to be the format that we're using. So in this case, we've used Gleaner to harvest and then convert to Turtle. We also then have a way of bringing it in from catalog services for web. We didn't readily find a tool, and I'm open to suggestions here on something that could instantly convert the ISO XML into Turtle or into an RDF format. So we just used some other libraries, and we adapted and created a tool that basically converts it over to the RDF model. So all of that then moves into what's known as a triple store or a semantic database. We use one called Jenna Fuseki, which I think many others use as well. It stores our triples, but allows us to execute Sparkle queries, which is how we've done the mediation or translation. It also then allows us to output in several formats. So again, using software that's already there. So really what we tried to do as well, there is some custom code that we're doing in Python, but wherever possible, we're trying to do this using Sparkle. So that we can be as interoperable as possible, and then just publish this out along with the endpoints and be able to translate from one catalog to the other. There's some results there that's in JSON LD, the format that we talked about prior. We're putting an API or application programming interface around this so that you can access it. You can access it as a Sparkle endpoint. But for some of those extra functions, there's this fast API that's being used. So our success that we think so far is that we've taken this CCADI semantic mediator, which currently privately publishes to. We're not quite ready to open that up to the world just because we're still polishing it, and we have another grant to do that. It's publishing to the Polar Data Catalog, which is a well-established catalog. It then publishes it to the Polar Federated Search. So that's where Chantal was talking about. We have a number of different repositories or catalogs that are now published through that. And that becomes essentially our graphical user interface or our end user interface that we point people to. We're also, we did a little bit less work on this, but we did some at the end of our current funding, or the funding that we're just wrapping up, or we're heading into some new funding, where we have data shared by partners. And it has metadata as well, but it's being exposed by different services, but DAP, ERDAP in particular is one of them. And what we've done is we're taking oceanographic data, and we are using existing standards, VODC and the NERC vocabulary server, et cetera. But we've created a crosswalk ontology that allows us to take from a very proprietary format, which is coming right off the ship and the rosettes and so on. We then translate that into a community standard form, which can then be published. And what we're working on with one of our partners in Manitoba in particular is how do we take that translated data and push that actually back into their repository so they have the original raw, but also the standardized form as something that they publish as the repository. So
Okay,
just
2
wrapping up
minutes.
here,
Yeah,
next
2 minutes left.
steps.
Sorry.
Have funding for a postdoctoral fellow, which I've had for a little while, but we've been delayed because of some COVID issues. But have a postdoc funding who's somebody who will help us out on the semantics side. We want to expand the data mediation because that's a big part of the work that our partners want to do. The software right now and the ontologies are working, but they're not in a form that we could just publish to the community, but we want to do a lot of work there. Work with the community on identifying tools and so on, and then use tools for related projects. So for example, have 2 projects that are focused on the use of genomics in non-expert communities, things like wildlife management in the north, and how do we translate across these knowledge domains from the expert genomics knowledge into areas where people are experts perhaps in wildlife management, but not the terminology and the data coming from genomics. And we're adapting these tools for use with that. And that includes also natural language processing, qualitative research, and community-led research. And I'll just finish with the slide that Ruth put to me with some of the tools and resources that we're using. Thank you.
Again, another great talk. Thank you so much, Peter.
Great. I'll stop my share now.
Okay, and Pierre is up next. And he'll be talking about the Ocean Info Hub and something called Unhide. So Pierre, take it away.
All right, thanks, Ruth. Yeah, most of the talk will be focused on the Ocean Info Hub. Unhide is a derivative of that we're implementing in the Helmholtz ecosystem. But the Ocean Info Hub project is something that IODE, the International Oceanographic Data and Information Exchange, part of UNESCO, is implementing with support from Flanders, so the government of Flanders, Kingdom of Belgium. And the idea of this project is really to sort of link off a whole number of partners in a lightweight architecture that includes lightweight semantics. It's very, very similar to what we've seen before and in this session, and that's no surprise because a lot of it's inspired by science on schema.org. In fact, the proposal for this project, Sky Bristol and I were invited to sort of consult on that way back in 2018, and it's sort of come to fruition since then. And our main thing was, please don't build another central database. The time is over. It's time to link resources using linked open data and the semantics that come along with it. So yeah, I'll just take a little tour through that. It's a 4-year project where we still have a bit of time left to continue implementation. We have some advertisements out actually for project managers and developers. But the main point is to improve access to discoverability of metadata across all sorts of digital capacity levels, right? So it's a democratization initiative. We need to also use that system of like getting that metadata out there to demonstrate how it can be linked together, how all of the participants in what is now the Ocean Data and Information System, so the sum of everyone sharing their metadata profiles, how that can actually become useful to many. And then also to make sure that we're developing this with the consultation of many partners from different regions around the world, different capacity levels, different digital cultures, and also reusing standard web architectural patterns as far as possible. Again, we need it to be such that you can hire somebody in a sub-Saharan African nation who will know how to implement this because it's a prevailing skill in the industry, for example. So as I said, it relies on this sort of lightweight implementation of semantics. Schema.org was chosen because it has this relaxed approach to semantics that's a blessing and a curse in some ways, but more a blessing in this case. And then we're just trying to use the UN's convening power and convention building power to sort of nudge that into a more, let's say, interoperable approach. The main idea is that when somebody, a practitioner queries some kind of data source, that shouldn't have to be the one data source to rule them all. That source itself should be able to query multiple other sources that are federated in this Otis federation. We actually call it the Otis Federation, to be able to report back to that source and give a reasonable answer. And we're building the sort of foundational layer for that as part of a larger program in the UN Ocean Decade of Science for Sustainable Development called Ocean Data 2030, which is sort of building this interoperability glue between some major regional data infrastructures and also small-scale data holders. So that's the idea. We hear about this one-stop shop thing, and that sort of keyword drives me a bit crazy. But we have to build a global supply chain if you want a one-stop shop, and that's where we're focused. It sort of picks up on a quote from Terry McConnell, who was seconded to UNESCO from Fugro, a large ocean company. And we had a G7 summit on digital twins of the ocean. And I liked the way that he phrased it. If you want to build these sparkly fountains, you need to do the plumbing first. And it's a lot less glamorous, but it's very necessary. So Otis and the Ocean Info Hub, they kind of are part of a family of projects in the IODE. It kind of lays on this Otis CAT, a catalog of sources, just like an index to tell you who has what are their institutes about, and where do I look for their metadata. With that index, those things, those partners become part of the Ocean Data and Information System, which is the sum of all the partners who have adopted these conventions and are trying to share data between each other. And then we built Ocean Info Hub on top of that to show how it all works and that it can work, so you can take it out to the funders in those countries and put it into their strategies and their 5-year plans and 10-year plans, et cetera, which is happening in some of our regions. It's the same principles we hear about a lot over here. It has to be sustainable. If OIH, when the project stops, this thing should still be viable. It shouldn't rely on central funding. There's no central hub. The nodes should be able to bilaterally share data if they want to, or put it into the commons. They control how they participate, and that's important for data sovereignty considerations, data localization considerations, legal frameworks that are popping up everywhere, etc. And the nice thing is anyone can develop whatever portal they want and pull the information from the nodes that share it in any way. So it could be a thematic node or a regional node. And again, that's why we keep it lightweight with the possibility of going deeper if you need to. So that's a sort of schematic of it. We have our UN systems that are kind of flowing their data in, and then external partners, and that list is growing. And from that, people can just pull out whatever they need and whatever their systems can understand. That interoperability architecture, so the Otis architecture, as we call it, Otis Arc, is based on it was a lot like Science on Schemas recommendations, JSON-LD schema.org templates, that are sort of documented out there in the UN, in our UNESCO documentation, so others can look at it and use schema.org and JSON-LD in similar ways. Because of course you can do a lot of interpretation, as I think Chantel said, it's very subjective. We're trying to sort of nudge that a little bit away from that subjectivity while keeping the flexibility, just by good documentation and showing that if you do it that way, good things happen. So, it looks like that. You can already sort of see that you can embed not just the schema.org semantics, but you can start including links off, PIDs off to other graphs, other semantic graphs, be that like the Dublin core or Wikidata, or even some of the more formal ontologies out there. You can actually go as deep as you want to in that. And I think that's going to be our future, because that lightweight interoperability layer can link off to then more formal graphs. And as far as semantic harmonization goes, when we scan the Uber graph of all of these things, we know which regions are using what and can start initiating harmonization processes. Again, eventually trying to make things more and more interoperable. So yeah, you build a graph, we stick them together. And from that graph, we build out the Ocean Info Hub graph. New patterns are being developed. Our partners come to us and say, like, this is from Odin Africa. They say, hey, look, we need a new pattern or a new sort of JSON-LD template plus schema.org for platforms and sensors. We say, cool, let's talk about it. What do you need? And then we try to implement it. The same is true for hazards and disasters, coming from another project that we're on, and for protected areas by some of the practitioners dealing with protected area management and mapping. So they tell us what kind of data fields they need, and we figure out how to implement that in this as close as we can with vanilla schema.org JSON-LD, drawing in some other semantics where necessary. We do a draft of what it looks like, and we see what happens. Sometimes we're just stuck at simple property values, saying, okay, we don't have a PID for this term yet, but we know a stakeholder needs that. And that's something we can hand off to the semantic development communities and say, hey, please build a good ontology for this, because the stakeholder base needs it. At least it's out there, and it's usable right away, and we can formalize it and harmonize it a bit later. That's the idea. So it dovetails with a lot of work we're doing here in ESIP, semantic tech, obviously, so obviously marine data, it's a natural fit. Biological data, so all of OBIS is indexed into the Otis system, so the biogeographic system. It goes on. And yeah, it's getting quite popular. A little bit more on that deeper semantics, we can take a look at these essential ocean variables that the Global Ocean Observing System and others use to sort of talk to policy. If you look at that serialization, you'll see that inside the schema.org variable measured, those property values can link to a Goose EOV, and then off to something like ENVO or the GCMD for the actual semantic description of that EOV along the Goose specifications. Yeah, so this is coming from an official document released by Goose to say, this is what we're talking about. And if you want to, you can even release some of the values so that your metadata can actually cross to the data layer, and you can maybe spin up more responsive interfaces. So that's, you know, we can go deep, and this is that link off to a lightweight graph, to a heavy lifting semantic artifact like Envo, or a large collection of keywords like GCMD. And again, it's another nexus of potential harmonization. This is why we're looking forward to releasing that paper that Ruth talked about earlier, because we need to train more people to know how to do this, because the need is great.
Two
Our
minutes left. Sorry.
Sure. Yep. Implementation regions, Latin America, Africa, and Pacific Island small developing states. Again, that was chosen so that this is tractable in a whole range of different capacities, and it's working quite well. About 50 partners are aligning. A subset of them are plugged into the graph, some of them major data providers and some of them minor. So it's working out. Also in the UN decade, there are international programs like for biomolecular observing networks and digital twinning of the oceans. And again, the Otis OIH is aiming to be, and is already in part, the interoperability layer for these, where specifications for data exchange are being developed for the UN systems and the sustainable development objectives. The interface is lightweight. It just takes those patterns, put them in a nice little interface with an array that smiles at you. You get your results back. All of that's just driven by the JSON-LD. And the same thing with the mapping. All of those geo regions are just in the JSON-LD, links back to OBIS in this case for biodata, and can be faceted based on the metadata. So all metadata driven. That's the summary. I think I've said it all already, so I won't spend my last few minutes on, but I will talk about where we're taking that in Helmholtz. Basically, we just cloned the system into Helmholtz, where we're going to change its flavor slightly to this unhide graph. Same logic as Otis, but instead of, let's say, the global partnership, it will be these 19 independent research centers in Helmholtz that are doing everything from synchrotron research to polar research, deep sea, whatever you want. So we're trying to connect their libraries, repositories, research infrastructures. It's like a microcosm of Otis, and it's going pretty well. So the whole idea is again, very much aligned, making that data discoverable through metadata, and it's working. So we basically cloned it in. We have the interface set up, again, a clone of the Ocean Info Hub database. There's a GitHub repo, it's all public. And we're going to try to tune that now into the Helmholtz needs. So of course, it can't be a one-to-one match, but the same logic, convention building to start building it. We just kicked it off in the last quarter of 2022, and we're already harvesting. We have about 95 million triples in there from earth science, from materials research, from just the GitLab projects, etc. So it's viable, it works, and it doesn't take coders much time to actually convert things because of those crosswalks we talked about from RDA. If somebody has DCAT, we can still merge it into the graph and produce that lightweight layer that will gear for deeper and deeper interoperability. Okay, I'll end there. You know, there's more to extend that we will do to link to our FDO stores or some of our own ontologies we're developing to describe our digital assets in Helmholtz. But you know, the process is viable, but needs more and more harmonization of semantics as we get into it. So thanks, Ruth, for bringing it all together in this session.
All right, well, thank you again. Yet another great talk. So now we have about 10 minutes, so actually more like 9. To answer questions. I will note there were only 3 in Slido and a number in the chat. So I think we should start with the Slido ones. So if DataCite uses schema.org and repositories mint DataCite DOIs, what is the benefit of the repository also implementing schema.org? And while I think that came up during Chantel's talk, I actually think almost any or all of our speakers probably have something to weigh in on this question. Anybody like to start?
Yeah, I can jump in real quick, Ruth, and then yeah, happy for anybody else to jump in and elaborate. So in the Polder world, DataCite implements the basic level of the metadata schema.org, so it's not domain specific. So for the polar federated search, if you're looking specifically for say polar keywords or temporal, spatial, something more specifically that can be discovered in the polar federated search, where it might not actually come through if it's not marked up in the DataCite kind of side feed, if that makes sense.
So you're saying DataCite is not as robust in terms of content?
Yes, thank you for being very more eloquent with that one, Ruth.
Okay. Anybody else? Okay.
No,
Next.
I think you know, like, that robustness, I think, comes from this middle layer that I think we're all sort of talking about somewhere in our systems, where you set a kind of conventional usage for something. And I think in our semantic harmonization group, we've been focusing on the ontology and the semantics itself. But I think maybe we should also broaden our scope to think about how those things are implemented, right? So how they're where's the guidance developed? How is it developed? And can we harmonize also the usage of semantics? We didn't really get to that because we were so focused on the terms in our previous work. But perhaps, Ruth, that's something that we can broaden out, especially if we get the expertise of the folks assembled here.
Well, that's a lead in to the last section. So I'm going to ignore that for the moment because we'll come back to that very shortly. And then, Peter, here's a question aimed at you. Is Otis focused on metadata exchange / search or harmonizing the underlying data structures?
Well, the first approximation is the metadata, right? Because I mean, we're dealing with some major infrastructures that are national, like the National Oceanographic Data Centers and others, that they're big machines to change. You know, so if we said, "Hey, everyone, change your NetCDF specification to this," they're going to balk at that. So first we said, all right, let's try to make the initial piece. It's diplomacy in a way. Make the initial sort of peace treaties around the metadata. Then when that starts working, the natural thing, and it's already happening actually quite early on, it's saying we want more. Like now we know that these 17 partners have data that we're interested in from the metadata graph, but now we hit that wall that the data is not interoperable. So, but that's what you need first, that willingness, because now they want to do it. Now it's not coming from a top-down source or just like one consortium competing with another. They've identified the whole group, as far as we can reach with Otis, of stakeholders that want to co-develop that, and then we can find a sort of middle ground there. There will be, of course, the high capacity nations doing their own thing and the lower capacity nations doing theirs. But hopefully with some of our convening power within the UNESCO system, we can then try to bridge something a little bit more tractable globally. So it's not so much a technical problem. It's like using metadata as the conversation starter to start the negotiations for the data interoperability. And again, we have to now identify those groups of people who have a data standard that they're willing to modify and meet in the middle, again, in a minimal way. So I think that's how we approach it.
Okay, thank you. And the next question is again for all the speakers. Where should emerging professionals who want to contribute to this type of work look to get involved or find employment? Anybody want to take that one?
Peter had a postdoc offer. Go to Peter.
I might just jump in on that one, and I say there are certainly. I'm in the academic sector. I'm an associate professor of geomatics. I am really struggling to find people who know how to do it, but also trying to work with the community to develop resources so that people who maybe don't know the specifics can be trained up. So that might be something to continue discussing as well. Because I think there are a few, not that many people in the community yet who can do this stuff.
No, I would strongly second that. I'm having trouble finding people who want to learn about this. I do have some postdoc money for about 18 months, 20 months, and I know that I think I'll defer to Emmanuel sitting on this call. But you know, Helmholtz also is looking for people like this. We know we need to do this. And I think there would be an opportunity there. Depends on the willingness and your ability to move around to Germany, say, in our case.
Okay, cool.
I
And
think it's
then,
also just, sorry, Ruth, it just occurred to me. I think it's also on us to a certain degree to kind of make the calls for these sort of professionals a little bit more clear, because again, at the higher levels of project management, a lot of the time this is just seen as another tech person, right? But this is a slightly different profile. It needs a little bit more, let's say, soft skills, humanities, interpretation, plus tech skills, plus, you know, network building skills. So I think, I don't know if there's some way we as a consortium can also make a statement, publish an editorial or something calling for giving the higher level project managers a heads up that, look, these people are going to be needed and they're needed right now.
that's a good suggestion. Hopefully somebody's capturing these. And then the last question on Slido is, are we now at a point where we can deploy more rapidly and realize real user benefits? Do we have ways to measure that?
Ruth, I answered that a little bit in the chat for life sciences at NASA. Part of the challenge in trying to do rapid deployments and rapid realization of functional gains is working with well-trained, very capable, very smart data scientists and data curators. Not all of them who appreciate the capabilities of semantic representations like ontologies, advanced semantic representations. And so we have to educate them on new processes and the benefits of these technologies. And it's just a little bit slow to do that kind of on a large scale.
Okay. Well, I think that's the time we had available for questions.
Oh,
I heard somebody. Okay, who was that? It must be.
Mark.
Oh, it's Mark. Okay, go ahead, Mark. One more.
all right, well, I wanted to follow up with Dan, and Dan and I are working in the same effort, so we understand the problems. I guess that this could open up a whole nother discussion, so we probably don't want to do that. But I just want to say that it seems like semantics are kind of on the edge of sort of maybe we're at the tipping point where it can actually become truly useful and that people will adopt it. And I think the conversations previously with Pierluigi about, you know, the capacity issues and the people that understand it and need it, and they're not just tech people, I think is really critical. The willingness issue that, you know, people see this as that it can actually solve problems. I mean, I think Pierluigi was talking about that as well. And I think that's the next big challenge for us is, you know, it's been a long ramp up to get the semantics in order, and we've got a lot of semantics in order. Now we have to make it truly useful, and we also have to have the capacity and the buy-in to make that happen. So sorry, that was a little speech, but yeah.
I think it's a good point. It also works the other way around. So one of the things we do in OIH, we don't clean up the results. So we harvest stuff, and if things are kind of weird, we show it like warts and all, we show the data results, right? And then when some of our funders or other stakeholders say, hey, why doesn't this work seamlessly or smoothly? It's like, well, the source semantics aren't great. And I think that's something we also have to show, that it's not, we always tend to filter that out, but we also have to show the issue of why it's needed alongside showing some of the solutions that are working. And then I think that'll make the light bulbs go off.
And you can't always go back to the source semantics aren't right, because the source semantics will never be right. But we have to have a sort of a critical mass of functionality that, you know, makes it good enough.
And that actually is a good segue right into our last discussion of the day, where I've created a Jamboard. If somebody would put that link into the chat, I'd love it. Where you can think about, after having listened to all of this and thought about your own situations in your own line of work, you know, what are the issues? Why is semantics not just sort of flooding in everywhere? And so if you would go to the Jamboard, I would like to spend 10 minutes and have people just, you know, put stuff on the Jamboard, you know, any and all of your thoughts, and we're going to be quiet for 10 minutes, and then we'll come back and hopefully have some discussions about what we're seeing on there, possibly getting maybe a little bit of organization started. Lastly, we will be capturing the chat. I do know there were a whole bunch of questions in the chat. Maybe not all of them got answered, but we'll save that chat, get it into our notes, and try and get answers to all those questions as well. So with that, I will shut up for 10 minutes and annotate away, please. And if anybody needs help, send somebody a note, like maybe even me. Okay, I'm going to break in here just for a second, because this page is getting really crowded. There is a second page, and if you want to start adding things there, that would be fine as well. Okay, I think people are slowing down a bit, and I do see some organization of the cards starting, but there are enough cards on here that I think the next 5 or 6 minutes is not going to be really quite long enough to totally organize them. But I can say that the whole point of this exercise was to help us figure out what we in the Semantic Technologies Committee and Harmonization Cluster at ESIP need to work on next. And some of the things I'm seeing in here are education related, quite a few of them even. And then there's this, so that's actually mostly in the upper left-hand corner of the first page and lower, a little towards the left, but middle maybe. But whereas up in the upper right, we have the whole culture and funding and issues, which, you know, in many cases, the questions that I see there are the same questions that you'd have with any kind of code. For example, you can find ontologies online, but how do you know if they'll be there, say, within 1, 5, or 10 years? And the answers are pretty much the same as they would be for any other kind of software. In other words, what kind of user community is it? What kind of repository is it in? For example, is it part of the Obo Foundry? Has it been updated in the last N days? Those sorts of things. It is very true that useful ontologies do keep disappearing because, particularly in the earth sciences, while maybe we can get ESIP to fix this problem, really, if you're not part of the Obo Foundry biology kind of world, there isn't really a repository. We have the ESIP's core ontology repository, but that in itself is not exactly what one would call well maintained, mostly because there hasn't been, you know, like dedicated funding to it or anything of that nature, which obviously, you know, it's nice that volunteers can do a lot, but you know, at some point you have to have something beyond volunteers. So those are the two that I could pick out pretty easily, but there's a lot written here. Anybody else want to take a stab at seeing at calling out a major area? I mean, I open the floor to you all, I think.
There seems to be a lot of talk on scarcity of expertise and other fields being more appealing.
Okay.
You know, like that AI ML thing, you know? So semantics and ontology, it's a branch of AI, right? So you have machine learning and knowledge representation as the two main branches of AI. And I think we don't emphasize that enough in a way, because if you want to really train your ML models well, having a data sourcing tool that understands what you're feeding them can actually help a lot. There are lots of cases where, you know, AIs are inappropriately trained and come to very bizarre conclusions. And I think that's a link maybe we should strengthen a little bit. There is the machine learning cluster, and they're writing a paper. I dropped into a couple of their calls. I don't know if anyone's here from that. And, you know, there was a statement, they're trying to figure out how to use knowledge graphs. Like, where does it fit into the whole ML world? And I think maybe we need to give that cluster a bit more attention and build a bridge there to say, look, we can figure it out and we can make a collective statement on how we can actually feed machine learning, and the results of machine learning can be recirculated back into a data commons with appropriate annotations and knowledge representation. Then we have much more of a data space kind of logic happening.
Actually, I agree with that totally. My own personal experience, having done some machine learning as well as natural language processing, is that ontologies, NLP, and ML can make kind of a little virtuous cycle where they all improve each other. And so I would agree with that statement. Any other comments? We're getting close to the top of the hour. I will note that we plan on taking, for example, this Jamboard and all the questions and answers that have come up, and doing an assessment at one of our upcoming telecons to, figure out what our next steps ought to be. And so with that, I think we should turn to what our 3 takeaways or shared insights are from this session. So I guess what I'm saying is if you care about any of these things and would like to help ESA, figure out what to do next in this space, please come to one of our upcoming meetings. They are in the document down towards the end. February 8th at 2 p.m. is a working session where we'll mostly be trying to finalize our harmonization paper, but February 15th is our regular monthly organizational call, where we will go over basically the materials that we gathered here today. So any thoughts on what should be our 3 takeaways or shared insights?
What Pierre Luigi just said about and you said, Ruth, of the cross connection between machine learning, NLP, and semantics.
Okay, I like that one, obviously, because I apparently cannot actually edit this while I'm sharing it. Drat. But I will note it down and put it in the notes. Okay, anything else?
I put one in the chat, like also seeing the kind of work being done here. It's broadening the whole notion of semantic harmonization, right? It's not just getting one ontology term to map to a vocabulary term. It's thinking, how do we use it? There's data structures themselves have a certain semantic. And if we kind of maybe think about how we can broaden that, we could probably make our cluster a bit more inclusive and easier to meld with some of the work happening in the other clusters. And I think that would be a lot more fun, because that's how we get to the applications, which we need to show people to make them realize how important it is to get the semantics right. So I think a little bit of more careful broadening of our mission can yield some positive benefits. The wording's in the chat, Ruth, so that can be copy pasted later.
Yeah, no, I saw that, and actually I was trying to summarize the NLP, semantics, machine learning all could benefit from each other comment as well. I think those are, 2 good takeaways.
I think it's kind of connected to that education thing. There needs to be a career path, right? Or like this skill has to be somehow connected to a career path to motivate, especially early career folks in learning it in the first place. Like, how do you use it to make your let's say your grad studies better, like your results better, or will it actually work for you to build a career? Right now, it's hard to see that because not many employers are articulating their needs very clearly. So I think that's another takeaway. We have to sort of help form the call for this skill set so that we can form a career path for others.
Yeah, I agree with that. Once upon a time, a long time ago, I used to teach data curation Foundation to Data Curation at the Graduate School of Library and Information Science, because I was trying to get the library community to understand that there were people who knew something about data management, that because they've been doing it for 50 years, that weren't librarians. And kind of that same process needs to happen again here, I think, to try and educate the broader community. Yeah, I just saw Dan's comments. Okay, I know that we're at the top of the hour, and I have to say that this has been, I think, a really, really exciting session. And I would like to thank you all for coming, and hopefully some or all of you will continue to participate in the various clusters and committees that are we're talking about here. And I need to, before we close this, I guess I need to capture the chat, because I certainly don't want to lose this, because there's so
Don't
much.
worry about that, Ruth. I've got it.
Great, thank you so much. All right, so I'd like to thank you all for coming, and I hope you enjoyed this and got good stuff out of it. And I guess it's time to go off and do the next thing. Thank you so much.